Hello, I'm Carly. In this video, we will explore the detailed procedure for configuring EB80 digital signal modules in ETHERCAT using Sysmax Studio. I will guide you step by step through the process in a simple and clear manner. Stay with me to find out everything you need to know about this topic. The digital signal modules include modules with 8 or 16 digital inputs, modules with 8, 6, or 16 digital outputs, and a configurable 16 digital signal module. We will illustrate how to parameterize some signals of a 16 input module, a 16 output module, and a configurable module. The other types of modules are similar, just change the index and subindex values. In the 16 digital inputs parameterization section, as usual, the SDO objects for communication are initialized. Then the parameters relating to the digital inputs are initialized. As you can see, with a single value, I parameterize multiple signals simultaneously. For each input, I can change the polarity, the activation status, any signal extension in milliseconds, and the addition of an anti-debounce filter in milliseconds. Now we focus on the usual part of the code that manages parameter writing, divided into communication opening, the writing part, and communication closing. Let's move on to the parameterization section for 16 digital outputs. The procedure is similar to that performed for the inputs. For each output, I can change the polarity, the activation status, and the signal status in case of communication interruption. As illustrated for the pilots, in order to set this last parameter, it is necessary to enable its modification, again via an SDO object indicated here. Otherwise, if the master does not communicate, by default all EB80 outputs are reset. The code for writing the output signal parameters is now shown. The S21 module parameterization section deals with the configurable module. With the I/O mask parameters, it is possible to set each of the 16 module signals as an input or output. The first 4 inputs have the additional option of being set as encoder channels, so a maximum of 2 2-channel encoders can be obtained. This configuration is obtained by changing the value of the first I/O mask. Signals set as inputs are parameterized as shown in the first section, while those set as outputs are parameterized as shown in the second section, simply with different indexes and subindexes. Here, on the other hand, we show how to parameterize a 2-channel encoder by changing the pulse count direction and choosing the encoder reset signal. All information relating to index, subindex, and instructions for parameterizing a single signal rather than multiple signals simultaneously can be found in the EB80 Plus EtherCAT manual on the website. For completeness, the code that writes the newly initialized parameters is shown. Let's move on to the mapping of digital signal modules. EB80 allows you to drive up to 16 modules with 8 signals, up to 22 modules with 6 signals, up to 8 modules with 16 signals, and up to 4 configurable modules. Let's go to the settings configuration, I/O map in the corresponding node. Let's suppose we want to map the newly parameterized modules. For the 16 digital output module, 2 bytes. For the 16 digital input module, again 2 bytes are occupied. For the configurable module, we have 3 bytes for the output data shown here. The first 2 are for any digital outputs, and the third for any encoder reset. Next, we have 10 bytes for input data. The first 2 are for inputs if configured. Then 4 bytes for reading encoder 1 and 4 bytes for reading encoder 2. I'll show an example of an ETHERCAT reset in case of a communication error. Now from the project menu, recompile controller. I'm going online. From the controller menu, transfer to controller, confirm. Great job. I hope you found this guide useful and clear. Thank you for watching this video with me.